Welcome students, we got an interesting question. So we have a circle and ABC is an equilateral triangle, and the objective is to find the area of the segment. And we have got a circle, two concentric circles. So we got a small circle. Let me write that down. So the area of the small circle is given to be as 80 square units. That's all we have been given. And ABCD is an equilateral triangle. So with that, we are expected to find this region, area of the segment which I have just shown you. So this is required. Now how are we going to get it? You can pause the video and try it out and then come back and watch the solution. Okay, I hope you all have got the required solution. So foremost, I would like to utilize this point that ABCD is equilateral triangle. So that would mean this is 60 degrees, this is 60 degrees, and this is 60 degrees. And then the area of the equilateral triangle is given to be as root of 3 over 4 a times, or I should say a squared square units, where a is the side of the equilateral triangle. So having got the two important information out, what I wish to do is I would like to draw an angle bisector at A. So if I were to draw that angle bisector, it would be actually hitting, this is the center, alright, concentric circle I have already mentioned to you. So this is going to be 30 degrees. So this angle is 30, this angle is 30. Okay, alright. Now do you notice this point? There is a point of tangency. So let me mention that from tangent theorem, the angle between the radii of the circle and the point of tangency is equal to 90 degrees. So that means this is going to be 90 degree. So let me connect that. Okay, so this is 90 degree, this is 30 degree, and 90 plus 30 is 120. So this is going to be 60 degree. So we have 30 degree, 60 degree, 90 degree right triangle. Right triangle. Okay, now if R be the radii of the small circle, right, if this is the radii of the small circle, then because we have 30 degree, 60 degree and 90 degree right triangle, this would mean the hypotenuse will be equal to 2 times the smallest side. Now which is the smallest side? This is the smallest side, and if I were to take this as OA is hypotenuse. So this would mean, because this is 90 over here, OA will be equal to 2 times of R, which is equal to 2R. So this entire length is going to be 2 times R. So that is a very important information we need. So if that is 2r. Can we say anything about the, okay, from here I can actually get the area if you are required, area of the bigger circle. So area of the large circle is equal to 2 pi times 2 times r raised to the power of 2, which is equal to 2 squared pi squared r squared, which is equal to pi of r squared. But pi of r squared, area of the small circle, is pi r squared, right, which is going to be 80. So this is going to be 4 times of 80, which is equal to 320 square units. Now this is not required, but it will come in handy if the question is a little bit different. If the question is a little bit, this question can be asked in so many different ways. So having got that is actually a good habit. Okay, now as I mentioned to you, we are actually looking to get this segment. So let us proceed in that direction. Now the next important step is we will have to connect this point of intersection between the side of the triangle and the circumference to the center. That's exactly what I'm going to do. If I were to do that, then I would get the all important triangle there. Okay, now clearly 2r, see, from the center to the circumference 2r, this is the radii of the bigger circle. Now this is also going to be 2r because from the center to the circumference. So you have a 2r here and a 2r there. Now that would mean this triangle is going to be an isosceles. So that in turn is going to mean that the base angle created would be the same. So the base angle created over here would be the same as the base angle created over here. I've already bisected A, which is 60 degrees. So this is going to be 30 degrees. So that would mean this is also 30 degrees. So 30 degree plus 30 degree is 60 degree. So we need 180 degrees. 60 plus 120. So that's going to give me 180. So this angle is going to be 120 degree. So clearly I can extract the area of the sector. So let me mention this particular point as OAD. So area of the sector is calculated. Area of the sector OAD is equal to theta divided by 360 times pi r squared. So my theta is 120. I have a 360 there multiplied with pi, and we are talking about the larger circle. So the area, the radius of the larger circle is 2 times r. So that is going to be the formula there. So 0 0 can be cancelled. 3 divides here 4 times. In fact, I can just say reduce it with 12. It doesn't matter. So 3 divides here 12 times. So 4 divides here 3 times. So you have pi over 3 times 2 squared, that's 4, and you got an r squared there, right? So this is going to be 4 pi r squared divided by 3. This is the sector area, right? So now comes the area of the triangle. So from this sector area, I'm going to take away the area of the triangle. So for that, we would have to use the tangent theorem. Now, what I'm going to do is I'm going to draw a line from the center to the point of tangency. So that is going to be making an angle of 90 degrees. Okay, so this is 90 degree. Now I need to know this base, right? If this is taken as the height, I already know this is r units, but the base has to be obtained. So I'm going to take this as some b1 and some b2. I do not know what is the exact division there. Now, a point of importance, this is an isosceles triangle. So if you were to bisect this isosceles triangle, you will actually have a 60 degree over here, 60 degree over here. So what I'm going to do is I'm going to take this point as some h, and I will consider first, let me use this space here, consider DHO, triangle DHO. So by Pythagoras theorem, so what do we get by Pythagoras theorem? DH squared plus OH squared is equal to OD squared. DH squared is B1 squared, OH squared, that is the radii of the smaller circle, that's going to be R squared, and OD squared is 2 times R squared. So this is equal to 4R squared negative R squared is equal to 3R squared is equal to B1 squared. Therefore B1 is equal to root of 3 times R. So we will be getting the same value over here also. So since B1 is equal to B2, this entire length dA is equal to root of 3R plus root of 3R is equal to 2 times of root of 3R, which is equal to 2R times root 3. Okay, so you can have that dA. Now I want to find the area of the triangle. So therefore area of triangle, I would like to have the area of OAD. OAD, that is nothing but half into base into height. So my base is found to be as 2 times R root of 3 multiplied into height. My height is going to be R units. So that is apparently the radii of the smaller circle. So that's R. This is equal to 2 and 2 gets cancelled. So R squared into root of 3. So this is the area of the triangle. So therefore required area is equal to area of the sector minus area of the triangle. So area of the sector, you've got it here, 4 over 3 pi R squared negative area of the triangle R squared into root of 3. I take R squared out and I can take pi out. No, I can't take pi out. So I take R squared out. I would get 4 over 3 pi negative root of 3. So this is the value that I have got. Now if you want, you can simplify this, right? Because we know that area of the smaller circle, so pi R squared is equal to, what is that, 80 units, right? 80 square units. So this is going to be 80. So from here R squared is equal to 80 divided by pi. So you can take up this value and substitute it here, 80 over pi, and you multiply 4 pi over 3 negative root 3. So that is going to give me, right, 8 pi and pi can be cancelled. So this is 80 pi multiplied with 4 pi over 3 negative 80 over pi times the root of 3. Pi can be cancelled. This is going to be 320 over 3 negative. This has to be resolved. Now if you resolve taking the value of pi to be as 22 over 7, this will give you 80 over 22 times 7 over root 3, right? So that is equal to 320 divided by 3 negative 560 divided by 22 times the root of 3. Now you can use your calculator. If you use your calculator, just in case if you want a value, so 320 divided by 3, so that is approximately 106.7 minus 560 multiplied with root of 3. So root of 3, this is going to be the value, divided by 22. So 44.0809. So 106.7 minus 44.09. So approximately 62.61 square units. So that is the area of this beautiful region. Right, from the area of the sector you take away the triangle area. So this is what is remaining. Now this is a lovely question. Please like, share and give your inferences. Until we meet again, enjoy your life. Thank you everybody.